Welcome to AP Calculus, Definite Integrals Part 2, the shell method. A different method to find the volume of a solid of revolution. So, whereas with the disc and washer, what we did is we found the area between two, actually what we did is we found that region and then we rotated it around an axis of revolution, make a nice solid, and then what we did is we basically found we sliced it up into a bunch of different discs and or washers, and then kind of like found the volume of very skinny pieces and added them all up together to find the volume of the whole thing. With the shell method, instead, what we're going to do is we're going to divide it up into really small cylindrical shells, find the area of each of those, the volume of each of those cylinders, and then add those up, and we'll continually make these cylinders make them skinnier as you move from the outside in. Alright, so what's going on is you're finding the volume of a cylinder that's really thin, and then moving it in a little bit farther, and then finding the volume of that cylinder, and then finding the volume of that cylinder, and then finding the volume of that cylinder, until we make to the point where the width of each part is really super skinny. So that's what we're doing. It's still, again, is a limit process, and it's actually kind of fun. Hey, let's review what we have done already. Let's review the disc and washer before we go on and show you the shell method. On a horizontal line. Okay. Let's see here. I want to see all those. Okay. When you revolve it around a horizontal line, it's going to be the integral from left to right. Oh yeah, don't forget about the pi. Love pi. Pi times the integral from left to right of the top function of x minus that axis of revolution, quantity squared, minus the bottom function of x minus the axis of revolution, quantity squared, all with respect to x. And then on a vertical line, it's pi times the integral from bottom to top of the right function of y minus the axis of revolution, quantity squared, minus the left function of y minus the axis of revolution, quantity squared, all of that with respect to y. Now the shell method is a little bit different. Okay, the vertical line, that is the one that is with respect to x, and it will be 2 pi times the integral from left to right x minus the axis of revolution times the top function of x minus the bottom function of x, all of that with respect to x. And then if you're going to revolve around a horizontal line with the shell method, you're going to go 2 pi times the integral from bottom to top of y minus the axis of revolution times the quantity, the right function of y minus the left function of y. The product of those two terms, all with respect to y. So, normally if we're revolving around a horizontal line, we'll use a disc and washer. And if we're revolving around a vertical line, we'll use the shell method, only because then they're left in terms of x. And that's usually the best thing to do, although sometimes it is definitely not the best thing to do. Alright, so let's go ahead and move on to the first example, and we'll try to show you how to use the shell method to find the volume of a solid. I forgot, before we move on, let's go ahead and look at the three-dimensional model thing going on. Alright, so that's what's coming up next. Alright, so here we have, right now, we've got two cylinders because our width is really small. So let's go ahead and make the width of each cylinder a little bit skinnier. We'll go all the way to 15 cylinder shells that we're going to find, and then as we sweep that around, because we're revolving this around the y-axis, we've got quite a cool solid thing going on. And I forgot to make it a cylinder. There you go. That's pretty cool, isn't it? So we're finding the volume of each one of these little cylinders going on here as it's getting spun around, and then we're adding those all up. That's the process. Alright, let's go hit an example. Alright, and just to make sure that you can actually see what that was, my face might have been in the way, so if you need to write that down now, you can. Alright, let's go ahead and move on to the first example. Find the volume of a solid of revolution formed by revolving around the y-axis. So here's going to be our axis of revolution, bounded by y equals 3 minus x squared, this parabola, the y-axis, and the positive x-axis. So our region is right here, and we are going to revolve that around the y-axis. Alright, so using the the shell method, we are going to do 2 pi times the integral from left to right, 0 to the square root of 3, x minus the axis of revolution is x equals 0, so x minus 0. Okay, the top function is 3 minus x squared. The bottom function is y equals 0, all with respect to x. So 2 pi times the integral from 0 to root 3 of x times 3 minus x squared dx, which in turn would be 2 pi times the integral from 0 to root 3 of 3x minus x cubed dx. We're ready to integrate now. 2 pi times 3 halves x squared minus x to the 4th over 4, evaluated at root 3 and 0. And that product is 9 pi over 2 when you evaluate it. If I have time, I'm going to come back and show you what it would be like to use the shell method. I'm sorry, the disc and washer method. I don't think I have time. So let's go ahead and move on to the next example. Alright, here we go. Find the volume of solid revolution formed by revolving around the line y equals -1, the region bounded by the x-axis, the y-axis, and the lines y equals 2 and y equals 2/3 x minus 4/3. Alrighty, so this time it is a horizontal line. Horizontal line means that for shell we need to have it in terms of y. So that means we need to solve this equation right here for y. That's probably the first thing we're going to do. No, solve it for x, I'm sorry, because it needs to be a function of y. Multiply everything by 3, and you got 3y equals 2x minus 4. 3y plus 4 equals 2x. 2x, you idiot. So 3/2 y plus 2 equals x. We are definitely going to need to do that. Alright, so we have 2 pi times the integral from bottom to top, 0 to 2. What was the axis of revolution again? Okay, y equals -1, so that would be y plus 1. Okay, the right function of y is x equals, that would be 3/2 y plus 2 minus the right function, which is x equals 0, all with respect to y. Let's clean this up a little bit. 2 pi times the integral from 0 to 2. Let's see here, we have 3/2 y squared. Okay, this will be 3/2 y and 2y plus 7/2 y plus 2 dy. Now we're ready to integrate 2 pi. Alright, let's see here. That would be 1/2 y cubed plus 7/4 y squared plus 2y evaluated at 2 and 0. And when you go ahead and evaluate that, substitute in and subtract and everything, you end up with 30 pi units cubed. Alright. And I think I'm going to end it with those two examples. I did a vertical line, I did a horizontal line. This will conclude definite integrals part 2, the shell method.